So our next speaker is Dr. Wilf Nixon. Dr. Wilf Nixon is the Vice President for Science and the Environment at the SALT Institute, a North American-based nonprofit trade association dedicated to advocating the many benefits of salt, particularly to ensure winter roadway safety, quality water, and healthy nutrition. Dr. Nixon received his bachelor's and doctorate degrees in engineering from Cambridge University, England. Wilf moved to the United States in 1984 to work in academia. In 1987, Wilf moved to the College of Engineering at the University of Iowa, became a professor in 1998. Wilf is now emeritus professor there, and Wilf has conducted research on topics relating to plow and cutting edge performance, optimal chemical usage, snow fence design, plow and truck instrumentation, optimal uses of novel technologies in winter maintenance, and information management and decision-making in winter maintenance. He's written over 100 papers and reports on his research and has made numerous presentations around the world. And if you have not had an opportunity to grab some of the booklets out front, please do so. That is also donated kindly from the SALT Institute. And so without much further ado, thank you, Wilf.
Thank you. Okay, we'll get me wide. All right.
There you go. And it should work as a clicker to go back and forth.
Okay. All right. Can you hear me now? Okay, we're good. All right, so today, excellent practices in winter maintenance operations, and I know from discussions with some colleagues, there was some question about what's this with excellent? I thought we were all best management practices. Well, there is actually method in the madness. First question, are there any lawyers in the audience? None? Really, none? Okay, this is basically a legal thing, because if you have best practices, lawyers will tell you that means you have to do it. You have no option. You've got to do the best. But if it's excellent, you can actually choose from among a variety of excellent practices and justify that choice, or at least lawyers feel that way. So, yeah, it's just semantics, but it's important that we remember there is not a one-size-fits-all solution to this. Not every practice is going to be ideal for every agency. Now, having said that, we're going to begin with 5, once we get into the application management practices, we're going to begin with 5 that are pretty fundamental. But just want to make it clear that just because something works well, for example, in Denver, doesn't mean it works well in Northern Virginia, and vice versa. Okay? Salt storage. The blue booklet deals with all that you might want to know in this. Really, what you're doing here is protecting your salt from the elements. It's not something that agencies get to do terribly often, to create a new salt storage facility, but it does happen, particularly with a larger agency. And if it does, there are a number of new things out there you can consider. SALTED is the acronym we came up with, very standard. It's all laid out in the blue booklet. But what I think is interesting is some of the ways in which agencies are trying to stretch their dollar and be more environmentally aware, are looking at things like shared facilities. The fact, yes, it's fine for us to say use brine, but then you need to store the brine somewhere. All those things have to be taken into account. And this is an example of a shared site. This is Fort Collins, Colorado. Both the city of Fort Collins and Colorado DOT use this. This stand along the front is basically a brine fueling station. You go there, it reads your truck number with a scanner. You fill it up with brine, and it can be brine, straight salt brine, or it can be one of a number of blended salt brines, which might include adding beet juice. Just a side note there, when somebody says, oh, we use beet juice. Yeah, you do, but it's only 10% of what you put on the road, typically. Okay, 90% is salt brine, or it's going to be a mixture of salt and calcium and magnesium chlorides. So yes, it helps, but it's not getting rid of the salt. It's still there. Nice salt storage in the background, a number of these liquid storage silos. Obviously, something like that isn't cheap. But then again, obviously, it's something you're not going to be building every year. There are some awesome facilities out there. There are some great tools that you can put into them. One of the ones that is very helpful is some sort of conveyor system to load the salt into your dome. That allows you to get a lot more salt in the dome. Various other ways. This is a European system here. It avoids that whole issue of using the front-end loader to pick up the salt and put it in the back of the truck. You just drive the truck underneath and a pre-metered quantity of salt gets loaded into the truck. Not without its drawbacks. There's an old saying which is very true, every solution has a problem, but it's a pretty neat solution nonetheless. A number of agencies now are looking into regional storage, not for their day-to-day salt usage, but for what you might call a strategic salt reserve. I think 12 cities around Des Moines share this facility, and it allows them to store enough salt that there is no reasonable possibility they will ever run out or run short of salt during the wintertime. That's very important to them because you can't guarantee salt deliveries in the wintertime. You know, right when you need the salt is when the roads are closed because of snow on the roads, which you could get rid of if you had the salt to break the bond between the snow and the road, but you can't get the salt because there's snow on the road. So, number of people doing that. Just a few photos from a new facility in Indiana DOT, where they put everything under one roof, their salt brine manufacturing, their storage, their wash bays, and their loading. They recycle the water from their wash bays for their trucks to go back into their salt brine production system. Okay, that helps them in a couple of ways, not least of which they are no longer discharging salty water into their sewer. And that's a good thing for their point of view. Application EMPs. There is nothing here that is not known. Okay, none of this is stunningly new in any way, shape, or form. In locations where people are facing a similar issue to here, namely high chlorides in the water, whether it's groundwater or surface water, we've identified 11 different areas. And over on the left, what I call the fundamental 5, those really are the ones that everyone should be doing. And then on the right, the secondary 6. Okay? They're things that, you know, you want to look at. But the first 5 are pretty critical. Everyone should be able to do those. And that's regardless of budget or any of those sorts of things. The second 6, they do require some investment. But if you use them properly, you'll get substantial cost reductions to the tune that you'll get payback within 1 to 3 winters. Okay? And that's not just if everything works right. That's pretty much everyone who has implemented these and stuck with the implementation has seen those cost reductions. The bottom line is any one of these 11 will help move you towards a more sustainable winter maintenance operation. Sustainable, achieving your end goals while minimizing the impacts on the environment, in this case. So the fundamental 5, everyone can do these. But if you aren't doing them right now, it's going to require change. So I say it's at minimal cost. There's nothing going to appear in your budget when you introduce these. But Phil made the very cogent point that in order to change, you need two things. Awareness, we can help you with that. Pain. Now, if you give me the tools, I can help you with that, but I wouldn't recommend it. There has to be a driver for the change. And none of these changes occur overnight. It's a culture change. Experience suggests to us that to really embed change in an organization, a transportation agency, is about a 5-year process. Okay? And the bad news is that if you don't keep up with it all the time, even after that 5 years, you can revert back before you know it. So this is not something you can just do once and say, oh, we've done that change, because if it's not an everyday thing, it's not going to stick. So the number one thing is calibration. This is simply measuring how much material comes out of the back of your truck. Okay? It's needed for liquids and solids, and it's absolutely fundamental. Okay? A lot of people have said to a variety of us who've done training in this area, well, it comes pre-calibrated from the factory. No. No, it does not. Little story about that, the Stevens Point experience. Stevens Point is a small city in Wisconsin. They attended one of our training events, and they were struck by this notion of doing calibration. So they went back from this, and they said, right, let's calibrate our trucks. Let's take a look and see. And they set up each of their trucks to put out the amount of material that they thought was the right amount. They were aiming for somewhere in the 300 to 400 pounds a lane mile range. They thought that would be good. First truck they did, 525 pounds a lane mile. Ouch, but not too horrendous. Okay, and correctable. Second truck, 1,325 pounds a lane mile, when they thought it was doing between 300 and 400 pounds a lane mile. Oops. In one winter season, 2 winters ago, they saved $75,000 in their salt budget just because they had calibrated their trucks. And they knew that they were now putting out between 350 and 400 pounds a lane mile. Now, that's just a beginning. That was about, for them, a 50% reduction in the quantity of salt that they used. So if your trucks ain't calibrated, well, you're just messing about. It's got to be the number one thing that happens. It also has to happen on a regular basis, and anytime any of the hydraulics get changed. And I think experience shows us, and I suspect Diana and Diane would agree with this, that the best way to calibrate is to get the operator and the mechanic who work on that truck to calibrate that truck together. Then no one can blame the other. All right? And then they both have ownership. So number one, calibration. Got to be done. Number two, measurement. If you don't measure it, you cannot manage it. What should you measure? Well, Andy made the point that we can measure more and more stuff these days. And you can. It's really easy. And it's going to get easier, and it's going to get cheaper. But what's important for an agency to measure? And this is one of these situations where, all right, there are lots of things we can do. We can look at how much salt we used over the whole winter. Good. We can look at how much we used over a single storm. Better. We can look at how much we used on a particular route. Better yet. We can compare what we used in different storms based on the storm type. You know, to go back to Stevens Point, their goal was 350 to 400 pounds a lane mile. The implication there is that every winter storm is the same. Have any of you seen 2 winter storms that are exactly the same? No, they don't happen. We'll get onto that in a while, but, you know, in particular, if you have what they call up in Canada salt vulnerable areas, you need to track what you apply in any watershed that has a salt vulnerable area associated with it. What sensors should you use? Bottom line is you don't want to measure something, if it's really important, in just one way. You want checks and balances. You want to measure it, yes, according to the calibration on the truck, we're applying this much, and I'll double check that by seeing how often I refill it during a shift, and does that make sense? So I thought I was putting out 200 pounds a lane mile. I covered 150 miles or lane miles during my shift, and I can do the math on that, and I can figure out that should be 30,000 pounds or 15 tons. But if I ended up loading 25 tons into my truck, there is something wrong. You double check all your important data. Accountability. It's great to talk about plans, but if you don't have a process whereby you actually check whether or not you're doing what you said you would do in your plan, you're wasting time. If you don't check what you're doing, it doesn't matter. Now, I think when I was here last time, well, not here, but when we last spoke, we talked about the peat problem. Anyone remember about peat? Okay. Don't be peat. All right. Don't be peat is the key thing here. You've got to close the loop. And that means getting down to the individual operator. Are they actually doing what you think they are doing and what they think they are doing? The they think is a calibration issue. The you think is an accountability issue. In other words, everyone has to be on board. And in fact, what we found is some of the best advocates for excellent practices are the operators themselves. They will do more to make programs like this successful than any management initiative if you get them on board. It's one of the things, wow, that's a lot of work to do. Well, it can be. But then again, if we do things the way we always have, we will get the results we've always got. And it was very clear from our very first introductory presentation this morning that we cannot keep on doing things the way we always have. We have to change. Okay. A systems approach to winter maintenance. If you look at the various things that go on, ultimately, it all comes back to this box. And we've talked about this a couple of times already today, the levels of service. And again, I talked about this last time I was here. This should drive everything we do. The level of service is our goal. It's the bullseye on the target, and everything we do has to be driven towards that bullseye. It's the old thing, if you don't know where you're going, you will end up somewhere else. And we cannot afford to end up somewhere else. The basics are pretty obvious, they're well known. Different roads have different priorities, you assign the priorities. It's things like we will achieve passable roads within 24 hours or 36 hours or 72 hours after the end of a storm. Different ways of looking at it. These are some examples of different classes of roads and what might be acceptable on them. Now, this is from my hometown in Iowa, so these are acceptable in that town. I can tell you, if you were looking in Chicago, the only level of service that would be acceptable in Chicago is this one. You will not be surprised to hear that Chicago has a chloride issue, and they are currently filing a variance so that they can hopefully be in compliance with their Department of Natural Resources or Illinois EPA in terms of chloride levels in some of the rivers around there. All right? But we've got to provide the right level of service. We don't get to decide as operators what is the right level of service. It is, and it should be, different for different communities. But, you know, obviously an interstate should be different from a county road. It's one of several things that impact winter maintenance, and it is primarily a political decision. And the challenge here is it's easy enough to get the politicians on board when you have them in a boardroom and you've talked about this and that. Oh yes, this sounds like a good thing. But are they on board when a constituent calls them up in the middle of a storm and says, my road hasn't been plowed yet? Because they have to be on board then. Otherwise, you know what's going to happen. They're going to call up the management of operations and say, plow this road. That's not in our level of service plan. Plow this road. You're going to tell the politician no? Politicians have to be got on board. It's interesting. You get into this right away. Yes, I've broken down these EMPs into discrete elements, but they're not. Level of service, very important practice, but it has to tie in with accountability. Experience suggests most agencies over-deliver on their levels of service. They get the roads in better condition than they are required to do. And yeah, I put down there somewhat cynically, it's to avoid complaints. That's not the whole reason. It's because the folks in the plow trucks want to make sure the roads are safe. After all, their families drive on those roads too. The only valid approach we found to get them to dial back on the safety is the mother-in-law method. Assign them the care of the road that their mother-in-law drives on. Okay? Doesn't always work, but it's a way. Levels of service is a big issue. Accountability ties into it directly. Okay, so try not to, I know just for ease of presentation, I've siloed all these ideas, but they do interact, and sometimes very strongly. Training. It's no good having new policies if you do not train your people in them. And the most important thing about this, it's not enough just to get your staff in a room and talk at them, sometimes seemingly without end. You've got to make sure they've learnt something as a result of the talking. And the more engaging you can make the training, the better. And if your training hasn't changed, your policies aren't going to change. You know, and good training is a wonderful tool for effecting change. And it's a tool that is too often overlooked. Okay, the second 6. These are ones where we know, and it's well documented by research and studies of a variety of types, that you can get your level of service while significantly reducing your material application by using these. But they all require new stuff. Okay, and that can be a barrier. We'll sort of identify what the costs, or at least what the cost components would be, and what sort of savings we might see as we go through this. Very first thing is variable application rate. I mentioned not every winter storm is the same. 3 key variables here. The number one is pavement temperature. Andy said it was more important than air temperature. I'd go even further. I would say I don't give a damn about air temperature. It's completely irrelevant operationally. The only thing that matters operationally is what is my pavement temperature, because that should determine how much material goes down on the road. Okay? What's my cycle time? everything we put on the road, if it's working, it starts to go into solution, and that means the clock is ticking. It's going to dilute out. If my cycle time is longer, I need to put more material on the road so it will take longer to dilute out and refreeze. If it's shorter, I can get away with putting less down. Okay? And then third thing, how much moisture is there in the snow or whatever that is falling? Light, fluffy snows, very little moisture. The white concrete that you get somewhere down here, your snow concrete, a lot of moisture. Same too in ice storms, a lot of moisture. What do you need to make this happen? Well, one thing you need is a chart and training for your operators. Second thing is equipment that can actually vary in the ways that the chart indicates, and not all of it can, but by the way, it has to be calibrated at the rates that you're going to use. Otherwise, it's just numbers on a dial and it doesn't actually mean anything. Okay? What we found is doing this, you can reduce your application rates by up to 50%. And that makes sense. If you think about it, if you have one rate and it's 400 pounds a lane mile, but it turns out most of your storms don't require that much, well, hey, yeah, you can save quite a lot. This is one chart. There are several out there. It just shows you, it's in fact two different charts. This is for a 2-hour route. This is for a 3-hour route. The colder the pavement temperature gets, the more material you put down. The wetter the precip gets, the more material you put down. So, it doesn't matter what the numbers are in the boxes. Well, obviously it does to a degree, but these work in Iowa. And these sorts of variations on a 2-hour route going from 350 pounds a lane mile down to 50 pounds a lane mile are the sort of variations in an application rate that you should be thinking about using. Forecasts, obviously critical. You've got to prepare. You've got to pre-stage your stuff. The important thing operationally is this little phrase here, pavement temperature. National Weather Service does not give us pavement temperature. They do give us surface temperature. Surface temperature, from the point of view of National Weather Service, is 2 meters above the ground. If your car is 2 meters above the ground, you have problems that are not going to be solved by any application of salt. Okay? They are going to be resolved fairly rapidly, but not in a good way. So, pavement temperature is critical. You probably need some sort of value-added meteorological service. And again, everything needs to focus on the pavement temperature. That's critical. That drives our application rate. Cold temperatures. As the temperature drops, salt takes longer to go into solution. It can't do any freeze point depressing, which is what we want it to do, until it goes into solution. And you see here, once you get to a pavement temperature of 15 degrees Fahrenheit, it takes about an hour for a pound of salt to go into solution. Now, some of it goes into solution right away, but you compare that at 30 degrees, where it takes 5 minutes for all of it to go into solution. Pavement temperature is very important, and once it gets too cold, we need to dial back on the salt and consider alternatives. The good news is, a pavement temperature during a storm of 15 degrees Fahrenheit here is climatologically very unusual. Not say it doesn't happen, but it's climatologically very unusual. A little bit of a nice statement that we think works is below 15, salt shouldn't be seen. You can push it below that if you pre-wet it. And the more you pre-wet it, we'll get on to pre-wetting, the better it will be, the lower it will go. Obviously, it can do some melting, actually down to minus 6.02 degrees Fahrenheit in the lab. But the road is not the lab. Operationally, on the road, 15 is about the limit until you start doing heavy pre-wetting. Okay, so below 15, salt shouldn't be seen. All right, what do you do if the pavement temperature does get below 15? What are your options then? Well, heavy pre-wetting with salt brine helps. Why? Because the salt brine is already in solution, and it's the time it takes to get into solution that is the problem here. In extreme circumstances, you might consider using other materials, magnesium chloride or calcium chloride. They will operate at lower pavement temperatures, but it's very unusual, extremely unusual for that to happen. In Iowa, which I think we would generally acknowledge tends to have colder winters than most of Northern Virginia, in the 30 years I've lived there, we've seen one storm where the pavement temperature got below 15 degrees Fahrenheit during the storm. Mind you, that was a doozy, but hey, once in 30 years, not too bad. Liquid usage. There are a bunch of ways you can use liquids. Prewetting and anti-icing are the two most common, but again, you can save up to 50% of your total material application by judicious use of liquids. These talk about the ways of doing it, but you've got to be able to make the brine. You've got to be able to store the brine. You've got to be able to apply the brine. You've got to be able to transfer the brine from the storage onto the trucks. There is a relatively substantial amount of infrastructure you have to add to get liquids. It's not insurmountable, but it's substantial. Pre-wetting. Pre-wetting is winter maintenance's proof of the old saying that it's better when it's wetter. Okay? We know, and we absolutely 100% know this, that if you add 5 to 10 gallons of brine per ton of salt, you do that on the truck, we can reduce our application rates by 30% and still get the same level of service. Why do we know that? Because if you put salt down dry, 30% goes straight into the ditch. It doesn't stop on the way, it goes straight into the ditch. This is known as pissing away your material. That's a technical term, all right? Let's see what we can do to avoid that. Okay, obviously you need liquid on-truck systems, and of course you've got to have a way of mixing the salt with the salt brine. Typical payback periods are less than 1 winter to perhaps 2 winters. This covers itself in cost very quickly, provided you remember to reduce your application rate. If you were putting 400 pounds a lane mile down dry and you put in pre-wetting, you can reduce your rate to 300 pounds a lane mile. But unfortunately, what often happens is it stays at 400 pounds a lane mile. It doesn't need to. You have to take the next step. This is part of that accountability. You've got to go back and close the loop. I know it's obvious, but I'm going to mention it anyway, and I think I just have. Why is this important? Studies back in the 1970s demonstrated that if you put it down dry, less than 50% stays on the lane where you apply it, and as much as 30% bounces straight into the ditch. If you put it down pre-wet, in this case it was 6 gallons per ton, more than 75% stayed in that center lane, and 4% was lost. Those are significant savings. And we're seeing, as we've gotten more and more experience with pre-wetting, You can pre-wet at higher rates and get even better performance than this. But you have to remember to turn down your application rate. Otherwise, it doesn't help you. Anti-icing, this sometimes gets confused with let's use liquids. It's more than that. It's a whole storm strategy. It involves getting out before the storm. You've got to put down a preventative layer of material, chemical, on the road before the storm starts. Now, if the storm is going to begin with rain, liquids don't help you in that circumstance. You need to put down pre-wet solids. But the bottom line here, again and again, studies have shown that you can reduce your total storm material usage by up to 75%. Why so much? Because you're not melting through the snowpack to get to the interface. You're already at the interface. The whole purpose of the chemical is to make it easier to plow off the snow and ice. The goal is not to melt the snow and ice. It's to stop it bonding to the pavement so that we can plow it off the road. And anti-icing is an extraordinarily efficient way of doing that. If you're going to do it, you've got to have the good forecasts, you've got to have pre-treatment capability, liquids, and practice. Okay, why do I say practice? I think everyone who has actually employed anti-icing has screwed up at least once. Okay, why? You're basing your actions on a forecast. And forecasts are wrong sometimes. Stunning to know, but occasionally those weather folk get it wrong. You know, being a meteorologist, it's a great job. You can be wrong more than half the time and still keep your job. I don't know of any other profession where that's true. So, conclusions. Storage, it's protecting your salt from the environment. Oh, which means you're protecting the environment from your salt. It's a two-way plus. Operations, fundamental 5. But if you're not doing those, what are the barriers? If you're not calibrating, why not? There are 17,000 agencies in the US that have some degree of responsibility for winter maintenance. It's our estimate that fewer than 5,000 of them have their trucks calibrated. The second 6, it's a progression. It's something that has to happen over time. You don't eat the elephant in one bite. There's a lot of change here. How much are you going to save? It depends on where you're starting from. We are all at different points along the scale. So maybe step 1 is to document where you really are right now. And I stress where you really are because I've been to visit a number of agencies, and let's say it's not uncommon to hear them say, oh yes, we do anti-icing, or we do pre-wetting, and you go out into the yard and only 2 of their trucks out of 20 are set up to be able to pre-wet. Well, yes, you do pre-wetting, but you don't do it everywhere, all right? Or every truck has liquid tanks on board, but we don't bother filling them anymore because they don't help. All right, maybe you're doing it wrong. A good, honest evaluation of where you are right now will show you where you can make progress and how you can move towards the end goal, which is basically safe and sustainable snow fighting. So, with that, any questions? Yes? How does this apply to taking care of sidewalks? Well, the same processes apply writ small, okay? The goal, if you want to be efficient about using your chemicals, is always to prevent the freezing to the sidewalk rather than go back in and try and get rid of that packed down snow. So much to my neighbor's consternation, when I moved into the neighborhood about, Lord, 22 years ago, the first winter came and a storm was coming, and I'm out there spreading salt. You know, and they're saying, what are you doing? It hasn't snowed yet. And I said, that's why I'm spreading salt. Because it'll be where it needs to be when the snow falls. And after they'd seen me cleaning it up so nicely and coming back to bare pavement so quickly, they were convinced. So same tools work. Now, application rates, a bit different. But it's nonetheless, these are good ways of doing it. I will confess, my hand casting is not well calibrated, though. Yeah? Nonetheless, getting it down there first is going to help me substantially, or has helped me substantially. And it becomes more and more important as I get older and less, you know, limber, shall we say. But yeah, the pre-treatment, the pre-application is a big help there. Yeah. Yeah.
Yeah, I just have a question about the application of brine and anti-icing, because it seems that sometimes you see brine application may be tried on the road.
Yeah.
And so what's the distinction there, and how effective might that become?
It's going to depend somewhat on the climate that you're dealing with, okay? If you have a lot of storms that begin with rain, then I would hope you would not see many of the safety stripes on the road, as we call them. In Iowa, most of our storms begin with straight snow, and the DOT, it's their standard operating procedure. If a storm is coming in, you will see safety stripes, you know, the lines of brine on all the interstates and all the DOT highways. Not every, slightly different in Iowa, cities and counties take care of their own roads, standard. The DOT doesn't at all. So some of them do anti-ice, some of them don't. How long will it stay there is another way of looking at that question. If I go out today and anti-ice, will it be there on Monday, right? 5 days away. And there are things you can do to increase its persistence. That's one of the major benefits, for example, of adding beet juice, because it's sticky. And it does improve the persistence. I think most agencies, you know, if you put it down and a storm doesn't come in, depending on your traffic levels, you may assume you've shot your bolt and you've got to reapply. Or you might say, well, if the storm was delayed by 12 hours, I'm probably still okay, as a preventative treatment. Diana, would you concur with that in general terms?
I would. There's a number of factors. The thing to just keep in mind is that it's a preventative treatment. It's a preventative treatment for getting the bond, and that's what you're trying to do.
Yeah.
There is a binding criteria, you know that.
Yeah. It works. You can't put it down now and expect it to work in 2 weeks' time, though. You know, it's got a lifetime. Yeah.
Quick question. You've been talking about the pavement temperature, and I'm not sure if I caught the connection between the ambient air temperature and is it relevant?
I don't think it is. The relationship between air temperature and pavement temperature is complicated, and that's putting it kindly. The models for road temperature tend to be very complicated because there are a lot more factors coming into it. How cold is your subbase? 3 feet below the ground has a factor. Pavements radiate heat, you know, and a concrete PCC, which tends to be lighter, will radiate less heat than an asphalt pavement, which is darker. And you can see that very clearly. So there are a number of factors, which is why pavement temperature is absolutely key. Because if that's where the material is, that's where you want the melting of a very thin layer of material to occur. Yeah.
So I think what that gets at is the issue with, you know, earlier we were talking about how some of the application, it isn't this large scale application. So we're all looking at our codes, seeing what the temperature is out there, right? So how does somebody translate that into, appropriate application?
There is no simple translation from air temperature to pavement temperature. What I do when I want to know the pavement temperature, I go online to the Iowa DOT website that shows all their road weather information stations, and I'm sure Virginia DOT has similar stations. And I look at an appropriate station near to where I am that I know has tracked well. Now, bear in mind, I'm geeky, so I've got various sensors, and I'm going out and measuring the stuff anyway. But I know which one tracks best with, my home situation. You may see, and one of my first attempts at pavement measuring was to get a little handheld gun off Amazon, temperature gun. And they are, I won't say useless, but they're next to useless, okay?
I think that's a wonderful.
We need to stop, right. Yeah.